All right, guys, this is your video lesson for wave interactions. So we're going to talk about how waves interact with other objects and with each other. The first interaction we're going to talk about is refraction. So this occurs when light travels through a different kind of medium. So remember, we're talking about medium means material. So when that wave changes materials that it's traveling through, it will bend. So if you look at this first picture up at the top, we look at this glass, so the light going through the glass is no longer straight. Do we see how it bends just a little bit when it goes through that glass? It changes its shape, and that's because it changes speed. Okay, all right, and if you look down at the bottom picture, you see refraction just like you do in the top picture. So in this one, it looks like the pencil is broken right here, and that's because the light has changed speed as it goes through the water instead of the air. So the top part of the pencil, you're still seeing that light travel through air, but the bottom part of the pencil, the light is traveling through the water. So it looks like that pencil is broken just because the light is traveling through a different medium. Promise that pencil is in one solid piece still. Okay. The next type of interaction we're going to talk about is reflection. So reflection we see all the time. Anything that light bounces off of, so we see it on mirrors, we see it on cars, you see it in glass. Anything that's bouncing that light back to you is reflecting that light. Now, this is also why we see different colors. When we can see things, it's because the light is reflecting off of it. So everything, all light can be reflected, all waves can be reflected, and that's why we see objects, is because there's light that allows us to see them. Now, if there was no light, we wouldn't be able to see anything. Right? The next interaction we're talking about is absorption. So absorption occurs when the waves are not reflected or transmitted by that medium, they're being taken in by that medium. So if we think about a sponge absorbing water, it's that same idea. The objects are absorbing that light. Okay? Now, when the waves are absorbed by that material, they are turned into infrared radiation, so they turn into heat. So a good example, a way to think about this and remember it, is when we talk about vehicles that sit out in the sun. If you're getting into a white car, it's going to be a lot cooler than if you're getting into a black car, and that's because white reflects that light, so it doesn't get as hot, but the black absorbs all those colors, so it's absorbing all of that energy, so it's going to be hotter than the white car. Now, the white car is not going to be cold by any means, but it's going to be a lot cooler than the black vehicle. And the next interaction we're going to talk about is transmission. So transmission occurs when a wave passes through a medium. Now, if we look over here at our picture of that stained glass window, we can see light through it still. So I can see the light coming through here. I can see the different colors of the fish compared to the water that's around them. But there's still some of that light is being absorbed by that window. Okay. So since it is a colored glass, it's still absorbing some of that light. It's not completely transmitted, it's passing through it, but some of that energy is still absorbed. Just a little bit of it, though, not all of it. So just a small amount of that energy is being absorbed. All right. So any kind of wave can be transmitted. So light can pass through a solid, liquid, or gas. Sound can pass through solids, liquids, and gases. But this is just the easy example to show you. Okay. Since we see light all around us, this is the easiest example for us to talk about. Okay. And now when we talk about things being transmitted, we talk about it in 3 different levels. So if everything is transmitted through that material, if it's completely clear, if we can see everything through it like we can a window or glasses, then it is called transparent. That means it's completely clear. Now, translucent is a little bit foggy, or like we think about that stained glass window we just saw, we call it translucent. So even though this glass over here is blue, we call it clear blue, you can still see through it, it just gives everything a color. We call it translucent because it's just a little bit foggy, or it has a slight color to it. Okay, so it's absorbing more of that energy than the transparent glass does. Okay. And the last word we use is opaque. Okay, that means it is not clear at all. You can't see anything through it, just like this mug over here, that green mug, the light inside. we can't see anything that's behind that mug. Now, if we moved around to the other side, we could, but we can't see through that mug. It is not clear at all. Another example would be like a notebook or a wall or a person. You can't see through them. Okay, so that's opaque. The next interaction we're going to talk about is when waves interfere with each other. So we just talked about how waves interact with other objects. We're going to talk about how waves interact with each other. So when waves travel near each other, they interfere with each other, and that interference can be constructive or destructive. So it can build or it can tear apart. Now, when we look at constructive interference, the waves line up with each other. So if we look at our diagram right here, if we're using this as our example, that trough lines up with another trough and the crest lines up with another crest. So they would stack neatly on top of each other if I was going to try and stack them together. Okay, that's what constructive interference would look like. Now, that what makes that wave a little bit larger, and it would make sound louder. Okay, so constructive interference builds up, it makes bigger, it makes louder, it makes things, makes them easier for us to hear. So that's constructive interference. Now, destructive interference is the exact opposite. It's when that crest doesn't line up with a crest. So the crest right here lines up with a trough instead of a crest. And if we were to try and stack these waves on top of each other, they wouldn't stack nice and neat. It would look something like this second diagram over here. Okay, so this makes the waves kind of cancel each other out. It will make sound quieter or more muffled, or it would make a picture, if it was light that's interfering with each other, it would make that picture kind of fuzzy or make it look foggy almost. So that's destructive interference. All right, and the last thing we need to talk about is something really, really neat. We're going to talk about cymatics. So in this first video right here, they're talking about the shape of sound. Okay, so different pitches will vibrate at different frequencies and create different shapes when we talk about what that would look like if we could visualize sound. Okay, so that's what that video is, and you'll see as the pitch increases, you're seeing that frequency increase, and you'll see there's more and more small little shapes bunched closer together. So when that video starts out, they're showing you really big pieces. They're showing you a really low frequency. So those wavelengths are larger, so they take up more space. So you're only going to see one or two shapes on that board. Okay, and then as the pitch increases, you're going to see those shapes get smaller and kind of closer together. So you're going to see more of them on that board. Now, just to clarify, what you're seeing in that video is a piece of either metal or wood. I'm not sure which one, but they've got that sitting on top of a speaker, and they're playing a frequency, they're playing a sound through that speaker that increases in frequency. So the pitch keeps getting higher and higher, and you'll see the shape of that sound change as the sound changes. Okay? And in the second video, they're taking that same idea and they're turning it into art. So this guy takes his music and puts he puts plates over the top of the speakers that have paint in them, and he kind of watered the paint down a little bit so it moves easier. So he's got that in there. He runs some tubing over some of the speakers and lets that water fall like kind of like it would be in a fountain. And he shows you how that shape changes the way things look. And so he's creating his music, but also giving it a shape so that we can see it. So it's not just the music that we're listening to, we're watching everything change shape as well. So it's giving us a really, really cool visual. So he's turning his music into a visual art form as well. And that's it. That's our lesson on wave interactions.